Alhamdulillah,
Good.
good.
Okay, Alhamdulillah.
Alhamdulillah, sir. Good.
Alhamdulillah.
So far, so good.
Okay, okay, so far good. That's good. That's very good. Okay, uh, let's just start our class today because we have some task to do. You have one assignment this week, and also you might have a quiz today. Better start now. So, do you remember what we discussed last week? I'm sure by take a look on this slide, you remember very well. We discussed about the S curve. Before I go through these slides and this topic, I have a question from you. Does anybody remember why we draw the S curve? What was
To
the,
get the critical point.
oh, sorry, again,
To get the critical point.
to critical point. Then there is another question rise. What is critical point? Maybe I forgot. What is that?
The main point.
What point?
The main point.
Main point. And I hear very many new terms today. What is the main point? Can you give me explanation? And your friends, maybe I missed something.
When we describe the function, there is some point it changes the function.
Function. Function of?
Any problem, any of like that.
Project process, I think you address.
Yes.
Okay. Thank you, Rashid. Anyone else want to share what you remember? Why we need, or what the curve trying to give us?
It represent the actual work and planning.
Okay, thank you. Yeah, that's the better definition so far you presented. Very good. Why I ask you this question? Because if you not keep reviewing in your mind why you learn this curve, then you will definitely forget it very soon as you leave the class. So keep in your mind, why should I learn this curve? What it's trying to give me, what knowledge trying to transfer to me. Okay, thanks everyone. Share your opinion, Bashir and the friends. Now let's go. Continue the S curve. The S curve defined as you can read here, a display of cumulative cost, but not limited to the cost, but also labor hour. Cost, labor hour, and we can also plot a different quantity of the project as a S curve to find out how is the process going on. You can, by drawing the S curve, you can answer those questions. Is the project on track, or we behind the schedule, or we ahead of the schedule. Right now, what we practice here today, we learn how to draw the S-curve manually, right? But in the future, if you work with a software like MS Project software, like a Primavera project software, the software automatically will give you the S-curve. But it's very important you learn what is the source of that S-curve, which you learn today. Okay, this is very clear that the name came from where, because the shape of this curve is look like the S or have a S shape. And beginning represent a slow, deliberate, but accelerating start. Okay, you can read it later. This is very common definition. But now, let's see, what is the different curve? We have physical S-curve, also financial S-curve. Both of these curves, which in basically their definition or the data that you extract the curve different. One is the physical work. What is the physical work? Like by finishing this month, 12% of whole project accomplished. By finishing today, 10% of the whole project fulfilled. And financial, as the name is very clear, means how much has been spent already. Okay, so, but for both of these S-curve can be baseline based on planned or actual S-curve. Means for the physical S-curve, you can have two types. The first curve is based on what you planned. Means what you calculate before project started. And another S-curve for the same thing, for the physical S-curve, during the project. For example, when you are on the 50%, 52%, 75% processing of the project. So you can have two curves to see how process is going on. I'm sure you get this because last week we show you two different color. If you remember, which I'm sure you remember, there was a blue color, there was a red color. Okay, one shows the planned, another shows the actual. So what it's trying to say here, you can draw for both physical and financial S-curve. Now let's have example. It's more clear when we see the issue on the example. Based on bar chart in previous example, construct the S-curve based on daily basis for this project, for financial S-curve, and for physical S-curve. Physical S-curve is based on resources, time, and work time. So let's see, when we draw it, what is going on. First of all, let's draw the financial S-curve. So when we want to work on financial S-curve, what column we need? Definitely we need activities, we need a start date, and okay, the most important here to address the financial S-curve is the cost column. I just make it highlight for you to get which one we need. So here we have based on the ringgit, but it can be based on any currency, euro, dollar, or anything else. Okay, take a look on the table. And Mohammed, there's nobody requesting at this moment. Maybe your friends already joined or have no request. And please join before 2 o'clock. Okay, let's see. Financial S-curve. Step 1, we will have to draw the bar charts, which include the cost of each activity. Why the emphasize on the cost of each activity? Because you are going to draw for financial, not physical S-curve. Okay, for financial. So you have activity on the first column on the left side, A, B, C, D. There's no need to mention to you that activity A is some activity on the site, such as excavation, installation, painting, okay? Could be anything. For simplicity, we just mention here A, B, C, D, okay? Each activity have different duration, 3 days, 5 days, 7 days, 5 days. That's really not issue at this moment, but the cost. The first activity A have 1,400. Second one, 2,700. Activity C, 3,500 until the last one. Now, what we have to do? We show it in the bar chart. Okay, take a look one more times. What is the green color? Is the duration. For example, activity A, 1, 2, 3 days. It's very important you draw it correctly, especially if you have in the test or exam or quiz. Activity B, 5 days. 1, 2, 3, 4, 5 days. One thing I have to emphasize here based on my experience, when students want to draw in the exam, sometimes some of them, not all of the students, some of the students will draw very messy, will draw the way that it's very hard to understand and very hard to give them mark, okay? Please draw it very clean if you have. I'm not saying you have, okay? It's not professional if I purposely tell you you have this or you have that. But sometimes there is a question about it. If you have, draw it carefully. And after all, I don't really remember what type of question you have because it's been more than 3 months we design your question. It's very, very long time. Now, let's go back here. You got the cost from the table, from your estimation, from your experience, from your quantity, from your pay slip or whatever. Now, what you have to do? You add one more column for cost per day. This 1,400 is the total cost of activity A. Total cost, right? But activity A took 3 days to done, which means you have to make it, you have to divide it to 3 to find out how much activity A costs per day. If 1,400 divided to 3, the answer is 467. I hope you can see the slide moving to the next figure, right? Let me know if you cannot see. How about activity B? 2,700 divided to 5 will be 540. So, which means you have 3 green bucks here, right? Each one needs 540 ringgit to that task fulfilled or finished. You do the same for other activity until the last one, which is activity F, cost 2,100 every single day. Okay, I have to ask you, can you see the slide properly?
Yeah, we can see the financial.
Yes,
Yes.
doctor.
Okay, that's very good. That's very good. That's very good. And if you have any question, you're always welcome to share your question. Okay, don't keep it in your heart. Just spell it out. Just share it. Let's maybe your friends have the same question, so everybody can use. So now let's see what in the next stage. Step 2, calculate the daily cost. You have it here. The first one, you already divide 1,400 to 3. You got 4, 6, 7. Okay. Step 3, calculate the total cost of each day. We haven't calculated the total cost for each day. We just calculate the cost for each day, right? Just like for activity D, we know on the day 15, 1,200 cost for activity D. But in this day, there is another activity running, which is activity C. What I'm trying to say, we need to calculate the total cost for every single day. What is our day here? 4th of, 5th will be May, right? Yeah, 4th of May, 5th of May, 6th, and until 24th of the May. I'm not good on the day and seasons, but you know better than me. This is the 4th. So let's see. The first day, how much does it cost? 467. So just put the figures there, how much you cost. Under this row, the cost based on per day. The first 3 days, you have only one activity, same activity A. So nothing changed. Just we put 467 for every single day for the first 3 days. Now, day 4, the cost changed because the activity changed. Activity B started. And on this day, on the 4th days of the project, which is 7th of May, there is only one activity running, right? Correct me if I'm wrong, okay? There is only one activity running, which is activity B. How much cost? Yes, 540. For the next 2 days, this is the same. But what if we reach to the day 7? Something changed because on the day of 10th of May, take a look here. There is 2 green box, right? Means 2 activity running at the same time. What you have to do? The sum of 2 figures will be your daily cost, which means follow the arrow, red arrow, 2 activity here, 540 plus 500, the answer is 1040. Okay, then we continue until the last day of the project, which is 24. We got for the last day 2100. This is the total daily cost, not total of the project cost. That's a different issue. We calculate next stage, next step, okay? So take a look here. Let me know if something not clear or missing for you. What we have to do is calculate the cumulative cost. So to evaluate this cumulative cost, you have to go on the first day of the project. Put whatever you have. What we have here? 467, right? Just put in the first box. This is what project spent so far. What project spent so far from the physical activity on the site. How about second day? How much the project spent, do you think? Just keep your calculator next to you. You can find it. The first day was 467 plus second day, which is the same amount. The cumulative cost for the second day will be equal to 934. Take a look here, read carefully, cumulative cost, which is the cost spent so far. So far only one day, right? Plus the current cost for the current day. You continue this trend until the last day. What you find is the total budget that needed for your project. It's very easy because the activity here is very easy. The project is very easy. Only 5, right? But what if you have 200 different activities? That will be much more complicated, right? So in that case, don't worry, we have a software to calculate. But you need to know, you need to technically know how that final cost will be calculated. Okay, so let's see. For third days, cumulative cost means what the project spent so far. 934 plus the current day, you got 1041. And if you continue until the last day of the project, which is 24 of May, the total cost is 30901. Okay. Take a look. Any question?
No, Doctor.
No, this
So far, no, Doctor.
Okay, okay, that's good. So let's continue. What next stage? We want to draw the S-curve, right? All the process we done so far is pushing us, is helping us to reach to the last stage. If we give up here, there is no point all this calculation. This is part of the process to draw the S-curve. So step 5 here, we will need to plot the graph based on the last thing we evaluate or assessed, cumulative cost. The last row here. Go back to the table to actually the bar chart here. The bottom line consider as 0. It should be, it's up to, it's need to be done by you, okay? The bottom line for your bar chart, the highlight yellow color, you need to consider as 0. Because at the first is you spend 0, you spend nothing. And also go to the top line. The top row where your bar chart start, consider it as your total cost, 3,900. Where I get this 3,900 from? The previous stage, the total cumulative cost, right? You can find it on the below right corner. So now you divide this bar chart to find the medium, means 50%. 3,900 divided to 2 will be 15,450. And also based on the number of the activity you have, this is a 6 activity. If there was 10 activity, this medium will be located on between the 5 activity, means 5 activity top, 5 activity down. Since we have only 6 activity, the medium will be middle of 3, means 3 activity below, 3 activity on the top. Okay, and the same way we can find another milestone, another mileage that we need. For example, between 50,450 and 0, you have another 2, which you divided to 3. Okay, you find 5,000 something, 10,000, 20,600, and 25,750. Okay, now let's see. Start from 0. I hope you can see this start from 0 in the slide. What was the first day? The cumulative of end of first day, 467. So determine it by some highlight, like multiply red that shows here. For second one, this row, the top line of activity F, consider as 5,150. So the 900, you can estimate where it approximately located. Same for 1,000. If you divide this box for activity F between the down line and top line to 5,000, 1,000 will be somewhere here. Until the last line, which is the total cumulative cost, you found all the different spot for every single day of the project for what you spend, for the cost. Now what you have to do, just attach the different spot together and you can find your S-curve. As you can see here, the S-curve here is not really in the standard S shape. That's because how the cost divided throughout the project. So it's not necessary that your curve will exactly follow the standard S shape. It sometimes depends to how much each activity costs for that specific project. So this is your graph for cumulative S. Take a look here. So this could be based on plan or based on actual progress. We didn't mention here. We just try to learn how to draw the S-curve, okay? If we have a different figure here to determine or to define the another issue, like if this is for actual, if we had also for planned, we could draw two curves. But that's not our discussion here. We wanted to discover how we can draw it. That's the way. Let me know if you have any question, so we can proceed to the next issue.
Doctor,
Yes.
is it same as design and build that we learn in chapter 3? The overlap cost that we need to ask. Is it same?
Is this the same as you learn from another subject, you say?
No, in chapter 3, the design and build part. The design and build, the cost that we need to do the design and build, is it overlap and we apply same in S-curve, financial S-curve?
I cannot really connect this issue to design and build. Yes, maybe this financial curve can use in any different situation, but I cannot specifically say this S-curve have any connection to design build. No, I cannot find any connection because that's a different issue, discussion. Let me put it this way. That's a different discussion which try to say how the relationship between different party can do the project. Okay, keep it there. Like maybe some project have project manager or some project does not have project manager and will done traditionally between only owner, stakeholder, and contractor and subcontractor. But in more update, you have consultant, you have project manager, they work parallelly under them, under their supervision. There are some contractor. That's a different discussion. Okay.
All right, doctor. Thank you.
Yeah. Regardless, you or anyone choose any of those methods like build, tender, construction, or any that 4 or 3 different method, they still can draw the S-curve for their project. They still can draw the S-curve for actual and planned of the project. Okay, so any other question? Please turn on your microphone and talk. It's good to have a discussion. Very good. And better if we have conversation, not monologue. I mean, I'm just talking, you're just listening. This is really traditional method of the teaching. And in new university around the world, even when I was lecturer in UTM, they told us to start this new method of teaching, that have discussion, have a discussion in the class, and you're not the one only who talk. So you're welcome to join. Okay, anything cross your mind, let me know. Turn on your microphone and talk. So that's for the financial S-curve. Now let's go to another issue, which is the physical S-curve. That was financial. Keep repeating your mind. Is about the cost you spend. Here, we have no discussion about the cost, but we want to see the progress of project based on the physical point of view. Okay, it doesn't mean we don't care about the cost. No, that's also, this physical is important as much as the cost or financial. But this is just, you're going to have a different view, different angle to the project. Let's see. This is your example. This is your question. Take a look on activity. You already got duration, a start date, the cost, which you don't need at this moment. But what you need is resource. Means how many worker you need every single day. This physical S-curve is based on the resource. Okay, ignore the last column and work progress. Just focus on resource day. But I have a question. Why the resource is important? That we bother ourselves to draw the S-curve for it. It just, take a look in this example, just 2 worker today, 3 worker on another activity, 2 worker. Is it really important that you bother yourself to draw anything for it? Any answer?
Yes,
Okay, yes.
because
Why?
the resources are limited.
How is limited?
Um, they have their own what I say like a setting for like for each day how many percent they can provide to make the work done.
Yes, correct, Yaka. Arya, Arya is the more easy name for me. Arya, thank you. Anyone else want to add any new answer to your friend? Respond. Think about it. Why resource is important? Yes, your friend said there are some limitation. You can add something else on it. Why resource important? If not important, let's not waste our time and proceed with another topic. But if you think is important, give a reason.
Because different resource will progress
Require
will have different work progress.
every task require different resource, different worker. Yeah, I agree with you. Anything else? I still didn't get the answer I'm looking for. That's why I keep asking, despite the answer of both of you correct. Okay, let's proceed. Maybe later you can find it and share with me. But think about it. Why the resource is important issue in the project. I would like you to think, and even if you cannot think of anything, Google it. Write it somewhere for later task. Now let's go back. The physical curve. Step 1, draw bar chart. Just like the previous financial, the first of all, you had to draw the bar chart. What is the bar chart? It's the green boxes you can see here, green bar. But this time, we have to talk about the resource. Resource means how many workers every single day need to work for the project. Activity A required 2 workers, but that's not all the issue because activity A will continue for 3 different days. So let's see. Day 1, 2. Second day, also 2. Third day, okay, same, 2 worker. Now let's move to activity B. 3 days, 3 days, 3 days. But on the next day, there are 2 activities running at the same time, right? So the cumulative, the sum of those 2 number will be your answer. 3 worker from activity B on this day and 2 worker from activity C on this day will be 3 plus 2, 5. And if you continue, you can find the number of workers that your project needed until the last day. So on the day 19, or let me take 19, you need the most number of the worker on your project, which is 13. So we found the resource based on per day. Now we need to calculate the cumulative for every single day. Exactly the process same as previous example for financial. The only different there we work with money or cost. Here we work with number of worker, but the process all is same. So 2 plus 2, 4, 4 plus 2, 6, 6 plus 3, 9. And if you continue, 1, 0, 1 means the total number of worker to fulfill this project. It's required 1, 0, 1 worker. So the next you have to plot the graph based on cumulative resource. Just, I don't need to repeat you again, same as previous task. You divide the lower bottom line from 0 and the top one, total cumulative, which is 101. You calculate it here and then divide it to the number of activity you have. Here we have 6, it already divided based on that 6. If you have more activity, you do the same. And then plot the graph based on cumulative resource, as you can see here. Okay, take a look. So what you see here is not necessary that your curve become a standard S. That depends to types of activity, that depends to what you want extract from a curve, such as financial, such as resources, or even the work progress. If there is no question, let's move to the physical S-curve based on the work and time. Previous one based on resource and time, right? Resource here and time, or daily here you can see. Here based on work and time. So the work progress percentage based on every single activity has shown in this column. Not every single day, okay? Every single activity. The total should be 100%. So here we got 6 activity, and every different one require different percentage. Now, same as the previous 2 example or some example on last week, you need to draw the bar chart, okay? So next, what you have to do, let me go to full screen. The activity A, by totally done or fulfill activity A, you accomplished only 12% of whole project progress. So 12% divided to 3, because there is 3 days for activity A, right? So each day means end of first day, 4% of whole project accomplished. This is same for second day and third day. Now, for activity B, you do the same calculation, 30% divided to 5 days. Every single day, 6% of whole project accomplished, and okay, same slide. This is, you do the same calculation for activity C, D, E, and F. Okay, take a look here. Now, step 2, calculate work progress for every single day. Day 1 4, day 2, day 3 same. The next 3 days, each one 6. But the next day, same as previous example, you should do summation or cumulative of 6 and 3, which is the result will be 9. So if you continue until the last day, you will got this row. Next step, calculate cumulative work progress percentage of each day. If you remember how we calculate the cumulative, the first day is same because there is no previous work before first day. So it should be same as work progress, 4. Then 4 plus 4, 8. 8 plus 4, 12. 12 plus 6, you got 18. And you continue until the last one, which is 100. Okay, just give me a second. A little shift here. Okay, so last day always should be 100 because we are discuss about work. So what should we do in the next step? You have to divide your bar chart from 0 to 100. 0 to 100. And then draw your S-curve. That's what you got from S-curve. If you compare the last three examples, you might see a difference between S-curve on different data that you analyze, which is completely acceptable and normal. So this one is your physical S-curve based on work percentage against or versus time. So what trying to say in this slide, so far we create the planning bar chart. What is the planning? Means what you estimated before project start. What if the real activity has started? How to create the actual S-curve? Think about it. What is different? Is it necessary to be different? Or the actual S-curve and physical S-curve can be same. Planning S-curve and actual S-curve can be same or not. It depends, right? It depends to so many variables, such as, can tell me, it depends to what? To actual S-curve and plan S-curve could be resemble, could be same.
Weather.
Yes, one of the reason could be weather, raining, climate, anything else.
Workers' Commission.
What you said, Mohammed, I didn't hear. You say very fast. Please spell slowly. Mohammed Amirul?
I think Workers' Commission.
Worker Commission. Okay.
I
Let
think
me.
he or she injured, I think.
Injury, accident, incident in the project. Yes. Actually, if we want to mention the case, the list will be very long list, okay? There are so many things because that's why we say the project is the unexpected process. That's why every single project is unique, is different from the next one in so many ways. The location, the type of the building, residential, commercial, the design of the building, the material of the building, the supplier of the material for construction, the attitude of the contractor, of the worker. All this reason will lead to we have two different curves for planning and for actual curve. Now, let's take a look here. The story getting more interesting. The example here is planning versus actual curve. We have one example here, but the difference, if you notice here, we have another column and two, right? What it addressing? The actual start date and actual finish date means the actual that activity finished. Sometimes you can see here, you can see here, you can see this activity, you can see in this activity is different from what you or project manager PM anticipated. That's why it's very obvious that you going or the project going to have two S-curve. Here, to show a more clear result, we depict the bar chart with two different color. The blue is the planning and yellow is the actual, means what is actually happening on the site. And you can clearly see the project faced delays. The project had not finished on time, right? So step one, you have to draw the bar chart. Step two, calculate cumulative for both planning and actual workday. As you can see here, I tried to highlight it, but somehow, okay, it's done. Take a look here. By right, you should know where this 1, 2, 3, 4, 5, 6, 8, and the rest came from. If you don't know, let me know, okay? And also the actual cumulative workday. Take a look here. Step 3, plot the S-curve. And finally, we draw our S-curve as a red color, address the actual planning, and I should call it brown color, maybe brown or chocolate color, I don't know, as the planning. So take a look here. The actual curve is below the planning curve. What does mean? I think I told you we talked about it last week, right? When actual is curve below the planning, it means you are behind the schedule. By right, they should be in the same line, or your actual, the red color here, should be on top the planning. So you finish the project earlier than expected time. But the worst scenario is when your actual curve is below your planning curve throughout your project, which is happened here. Okay, you don't want something like that happen in your future. And one more time, I want to remind you, for those of you who haven't registered for the workshop, which is coming in few more days, please attend. This is very good for your common knowledge because everything we study last week, this week, and next 2 weeks, you will learn how it's working in the software. This is good for your future because, one more time I say, if you know how to work with MS Project, your salary may be increased 20-30% every single month. That's a huge income. Don't miss that chance. This is for you, okay? So that's it for today class. Now there is an assignment. You have to submit it by 11. Since the 11 you have workshop, I rather to change it on 12. Just give you more opportunity. But don't submit it after 7 p.m. That's a deadline. You may take a note of the assignment. After you take a note or take a picture, prepare one piece of paper and pen. That's an individual assignment. It's not group, okay? Everyone, please join to this link. That's where you have to submit this assignment and also your later in the future, in few weeks, your group project. So everybody, please join to this link, the one I will share with you. I don't know why it's copied wrongly. Let me try again. Okay, this is the link. Everyone, join to this link for submit. I repeat again, this assignment and your future group project. All should be submit through here. Okay, and this is the link for submission. The deadline, as you mentioned, as you can see here, 12, which means next Sunday, right? Yeah, next Sunday, 7 p.m.